Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and what I'm going to cover in this short lesson is a thing called a union. And a union is like a struct, but a little bit different. So our design of it will look very much like a struct, and again, it can hold different types within it. But unlike the structure, it doesn't actually hold the space for all of those types at the one time. So as I say, it's like a structure, but the members of the structure of this thing of the union share the same memory or the same storage space. So if you've got a float and an int, they actually sit in the same few bytes, and you can only access one of them at a time. Okay, so this is because there are sometimes situations in a program where some variables may not be as relevant to this particular part of the program as others, and therefore, while they might both be related, you want to only use one of them at a time. So this is particularly useful in situations whereby you want the convenience of a structure, but you can't afford all the room that it takes up. So embedded systems would be a particular example where you're very, very limited for space, and this may be the best way about designing your program. So a union shares the space instead of wasting the storage on variables that are not being used. And it's to say, just like a struct, the members of a union can be of any data type. But, and this is important, the number of bytes that the union will actually take up, okay, as I said, they're shared, but the number of bytes that it will take up must be at least the size of the largest member of that, so that it can hold the largest member. So that's not really something you need to, it's not something you need to code into it, but it is something you need to be aware of with regard to the overall size of the union. You might think you're getting away with it being very small, but in actual fact, if you've got a large member in there, then the union will be at least the size of that large member. So I'm going to write a little union here just to show you how it goes. In fact, I'll write it outside main just to, so okay, so you use the word union instead of struct. We're just going to call this number. As you can see there again, this version of dev.c has completed the closing brace and put the semicolon there. That semicolon is important, so if you find yourself writing it and you leave that out, that will cause issues for you. Okay, so what I've done here is I've created an integer called x and a floating point number called y. Now, these both take up the same number of bytes as it happens on this system, but I could easily change this to a double for double precision, and that would take up 4 more bytes than the int would take up. But I'm going to leave it as float, so that's what we're more used to using. And again, unless you have good reason to be using double precision, you really don't want to be wasting space. So you can see one of them is called x and the other is called y. One is an int and the other is a float, and the two can't be used. You can't use ints and floats interchangeably, or at least not that easy. Okay. Now, when it comes to creating one of these, remember that union up there, just like the struct before it was, before we'd actually made an object of it, that's literally just the blueprint for it up there that we've written. So what we want to do is we want to create a variable of type number. So we do that as follows. We say union. And again, you'll see that this is very like the way we do it for a struct. So we'll just call this one value. And I can assign it a starting value, something like 10, and I prefer to have that up there like that, with the semicolon at the end. Now, it's okay to do that because the first element of it is an integer, and therefore if I put the value 10 in there like that, that will put that value 10 into the integer. So it's okay to initialize it in that way. But if we did something like the following, value, and assigned it 10.52 or 10.53 as I've done there, that could cause you issues. It will try and put that into the integer, probably only put the value of 10 in there. It may also throw you a bit of a warning to say, you're assigning a floating point number to an integer. So it's not that by doing that the system has the intelligence to realize that that's a float, and therefore I should go down and look for one of the variables that is a float. Okay, so it doesn't quite work that way when it comes to initialization. We'd have to be very definite about which member we were putting it to if it wasn't the first member of the union. Okay, so it's generally not a good idea to do that. So don't get into the habit of doing it, assuming that that's going to work. Now the other way of doing it, of course, is if we don't give it a value here at all, we can just set a number to it later on. So we do that by doing the following: value dot x is assigned 10. Okay. And so that's clearly going to put that into an integer. Now what I'm going to do at this point is I'm going to do a printf. And I'm going to print out both of the members of the union so that you can see what comes out. So I'm going to say x is %d, and I'm going to do a /n, so it's on a new line. Y is %f for float, /n, close the quotes, and we'll just say value dot x comma value dot y, and we'll take a look at what gets printed out for that. So as you've seen, I've called this union test in order to test this program. Be careful, don't call a program by the same name as the as a keyword, because generally speaking that can cause trouble. You might get away with it, but it's usually not a good idea, particularly if you're going to be using it in a larger system. Okay, so if you look at the results that we got there, x has come out fine as 10, but when we try and put the value y out, which remember contains the exact same 4 bytes, so it's contained in the exact same place, but it comes out as 0.0, so it hasn't figured that correctly at all, and that's because the two things are not the same. One is an integer and the other is a float. So what we're going to do is we're going to do it the other way around now. This time we're going to put value dot y to be assigned, and we'll give it a value of 10.53 like I did earlier. Okay, and once again I'm going to use my printf function that I used here previously. And remember now, we're now overwriting. We haven't overwritten the value of x. If you notice, what we've done is we've overwritten the value of y with a floating point number. So you may think that the value of x is still there. We'll see what occurs here. Okay, so we now see that the value of x in this case has come out as a very large number. Probably no point in reading it out, but it's somewhere around the 1,093,171,937, which is clearly just a bogus number that has appeared from there. Meanwhile, y has come out properly as 10.53. So what we see here is that by overwriting y, that has also overwritten x, but it's overwritten x with a variable that has been described or has been laid out as a floating point number, and therefore makes no sense as an integer. So unions are very useful from this point of view, that you can use several different variables, use the same memory space. It's very good for being efficient with your memory space, but you have to be very, very careful with the way it's used, and you need to know which variable you're currently dealing with. It doesn't really have the intelligence to try and figure that out for you. So while it can be very, very useful to use, it is important that you're aware that you are the one, as in you, the programmer, are responsible for how it is used, where it is used, and it can go, can make mistakes on you if you don't take very good care of that. Okay, so that's all I'm going to say on the unions for the moment. We're going to be going back and looking at more on structs which are of more general use to us, but it's important that you've seen that particular one because you may come across it again.